Welcome back, everybody. In this video, we're going to continue talking about hypothesis testing for means, also with the population standard deviation known. But in this video, we're going to consider another way to hypothesis test, which uses critical values. So in the video here, I'm going to show you how to find the critical values in a left-tailed, right-tailed, or two-tailed test. Similar to the last video, we've actually seen this function before. So we're going to use the norm inverse function. So we're using the normal curve here, inverse as an opposite. So instead of finding the areas, we're going to be putting the areas in and finding the z-scores. And those z-scores will be our critical values or our critical z's here. So the basic setup here is that when you use norm inverse, we always have to input the area to the left. And then you input your mean and standard deviation. Because we're doing z-scores in this particular type of problem, our mean is 0 and our standard deviation is 1. Now, your left-tailed test is straightforward. So if I do my norm inverse, your alpha here will end up being the area in the left tail as well. We always use norm inverse as area to the left. So that 0.05, you're just going to go ahead and plug right in. I'll use 0 and 1 for my mean and standard deviation. And there is going to be your critical z-score. So negative 1.645. So again, area to the left or left tail test is very straightforward. So we put it in just as whatever your alpha is, and then 0, 1. Now for the right tail test, you have some work to do first. So the way Excel works is they always want the area to the left. So what's happening here is that alpha value is on the right side of the graph. So the right tail is shaded in as 0.05, not the left side. So that means that the right side has that 0.05, and I need to know what's on the left. So in order to figure that out, what I could do is take 1 and subtract it with whatever my alpha is. And that would give me the area to the left. So in this particular case, I would do 1 minus 0.05, which is 0.95. So when I use my function here, the norm inverse, instead I'm going to type in 0.95 and then still 0, 1, and we'll get the right side of that test. So 1.645. Now you will notice that because the graph is symmetric, you do see the same value here, but 1 negative and 1 positive. You can also keep that in mind when doing these tests, that you will get similar values here for left and right tail tests, but 1 would be negative and 1 would be positive. Now the last one, your two-tailed test, is a little bit different. So your alpha here is getting split in half into 2 tails. So the way you're going to start first is you're going to take whatever your alpha is, and you're going to divide it by 2. So in this case, we're looking at 0.05, and we're going to go ahead and cut that in half. And when we do that, we get 0.025. So in my formula, norm inverse, I'm going to use this probability instead. Still 0, 1, oops, and hit enter. And that would give us the left side for the critical value. And don't forget, you also have 1 on the right side, right? Because it's 2 tailed, so you would have 1 on each side. So you would use the same value, but the opposite sign there. So negative 1.96 and positive 1.96. Those would be your 2 critical values here. So again, just to recap, this video is specifically for hypothesis testing for means with population standard deviation known. And in this video, you would be using the critical value method to hypothesis test. So we can use Excel to find those critical values. In all cases, we're using the norm inverse function. For a left tail test, that is your most straightforward one. You're just use your alpha here for your probability. For a right tail test, you would have to subtract the alpha with 1. So when we use our function, we're using sort of like the opposite probability there. Instead, 0.95 here. And then for two-tail tests, that alpha is getting cut in half. Half of it goes in each tail. So when you use your formula, again, make sure you cut that alpha in half. And then don't forget, you also need a positive version. So you should have 1 negative and 1 positive version. I hope you found this video helpful and you got to learn another application of the norm inverse function.